Now, I know the notes probably maybe look a little long, but it's just because of all the pictures. We're analyzing the graphs, so we're going to be looking at getting some information off of them. Also, don't forget, of course, this week you have a quiz on Thursday. Normally, I would have had your quiz on Wednesday, but Wednesday, remember, is the late start, so we're short class time. So that's why I moved it, obviously, to Thursday. I mean, why are we in school? A 4-day week and a late start? Okay, so here's what we got today. How to find values of a function from the graph. Now, values of a function, points off the graph is really what that is. Domain and range. Domain, how far left and right, sideways the graph goes, how far up and down for range. Okay, that's not so bad. How to compare function values, solving equations and inequalities graphically. We've looked at that in the last chapter, solving our inequalities off the graph. We're going to look at it today too. I'm just going to show you a little different style to it. You can do the same as last chapter though also when we get to that. This is probably new to you, increasing and decreasing. We want to look at where the graph is rising versus where it's falling. So we're going to take a look at that, and then max and min, we can do that all on your graphing calculator. So calculator day, for sure. All right, so take a look. This looks super wordy for something that I promise is very simple. So values of a function. The function t, graph below, gives the temperature between noon and 6 p.m. at a certain weather station. Find t of 1, t of 3, and t of 5. Now t, of course, is the temperature. So what this stuff is really asking you, what's the temperature at 1 o'clock, temperature at 3 o'clock, temperature at 5 o'clock. So I'm literally looking at the graph. So at 1, the temperature is right there, halfway between 20 and 30, 25. And I'm just going to put a nice little label on it. I'm going to do t of 3 in blue. So again, when the 3, up to the graph, it's 30 degrees Fahrenheit. And then let's do this one in black, 5. And of course our temperature straight over there at 20 degrees. That is getting functions off the graph. Remember, those are really ordered pairs. 1, 25, 3, 30, 5, 20, just getting them off the graph. Different style to look at it. All right, B, which is larger? Let me erase my little dots here. T of 2, T of 2, right here, looking at that point, versus T of 4. Now, I could actually write down like I did in A what the values are, but let's not really overthink this. Look at the graph. Which is larger, the green or the blue? The green, the first one. So T of 2. Okay, like it. Erase my dots off. Okay, C, find the values for x, so you're finding the x's, the left and right, for t of x equals 25. So I'm looking at 25 up here, and I'm looking at what the x coordinates are that hit 25. Well, we got 25 there, 25 there, so I just need the corresponding x's. 1, and of course 4. So I'm going to write 1 and 4. Now, technically those are at time values, so just to make it look fancy, I'm going to say 1 o'clock and 4 o'clock. Just so it goes in line with our word problem here, of course. Let me erase my little green. And the last thing, find the net change in temperature from 1 to 3. So we talked about net change in the previous section. So at 1, which of course we're right there in the middle, 25. Just going to jot it down here because we can mental math it. And then 3. Bless you. We're right there at 30. So what is the net change from 25 to 30? Final answer. 25 to 30. 5. And of course, that's our temperature. So I'm going to label it with our problem. We're in Fahrenheit. Got it. So just interpreting some information off of the graph. That's as wild as that gets. All right, domain and range. Now, domain and range, big topics when we're talking about functions and analyzing graphs. You will see this come up many times throughout this year. Domain, of course, we can read all this good stuff. Can be obtained from a graph shown in a figure. Domain is the set of all x values, and range is the y. So, I wish we had color copy machines for you, because the key here doesn't even show it the best on mine. Domain, of course, they're showing you this kind of blue here. So domain, of course, x. So anytime I look at a graph, I can get the domain just simply by looking at how far left to how far right does the graph cover. So I'm always thinking horizontal for domain. And then range, I have a pink color here, I'm going to do it in red. Range is your lowest to the highest. You're looking at your y-axis, which runs vertically. So I'm going to look for the lowest point up to the highest point. So we're going to look at some graphs now. I'm not going to give you equations or anything. We should be able to just look at the picture and be able to figure out domain and range. We're going to practice that a little bit. So many pictures. All right, use a graphing calculator to draw the graph. Now, I didn't give you a grid. I don't need any fancy, graph, but we do need to take a look at it here. So let's type this guy in. Minus x squared. And again, just if any time your window doesn't look like mine, don't forget you hit zoom 6, puts you back in the 10 by 10. Now, power of the smart board. There's my sketch of the graph. You might want to just, it doesn't have to be elaborate, but just draw yourself a little half circle there. Draw yourself a little half circle. So we have the sketch, so then we can do domain and range. You definitely need a calculator. So let me give you a two that. So just a little sketch, nothing super accurate. If I want it to look nice and pretty on a quiz or test, of course, I would give you the graph grid for you to mark it out and draw it. I just need a little sketch here. A sketch of Ruski. Now, domain. Domain, of course, is our x values. Or on our graph, we're looking left to right. So I'm like, okay, all right. So left, it starts right here, and it ends there. So easiest way, I think, to give domain is in interval notation. It starts at -2, and it ends at 2. So I'm just going to say it's the interval -2 to 2. Now, I like interval notation. I think it's crystal clear from the smallest to the biggest. Some kids like the inequalities. I don't really care if you like inequalities. You can say this too. It's in between. X is in between -2 and 2. You don't have to write both styles. I'll take either version of the answer, whatever makes sense to you. Okay, let's do range, which is y. And of course, my y-axis runs vertically. So I'm looking from the lowest to the highest. Well, clearly here's our lowest points, which are both on the x-axis, like that ordered pairs 2, 0. So what I really care about is the zeros. My lowest points are 0 for y, and it ends right at the top there at 2. So easy interval notation, I'm going to say it's from 0 to 2 for the range. Or if you like an inequality style answer, I'm going to pretty much do the same thing, but with 0, 2, and I'm changing the variable to y. I don't care which version of those answers you give, as long as you can get it. Okay, next thing I'm going to show you, of course, how to solve equations and inequalities on the graphs. Now, we have done inequalities in the last chapter. It's kind of the same thing, obviously, but a little twist to it today. So let's first talk about solving equations. Solution of the equation f of x equals g of x are the values of x at which the two graphs intersect. You're looking for where they meet, where they have the same points in common. And your calculator has an intersect function on it, which I'm going to show you. It's going to do all the work for us, which is super fun. Okay. Now, inequalities. So the points of the graph of g is higher than the graph of f, the points where the values of g are greater. Oh boy, that's wordy. And you can see there's a picture there on your notes, which I've got on the next slide. I couldn't just fit it on the same one. So to me, I'm like, holy cow, that's wordy. I think the picture is a better description for you. Let's look at the picture. So equal. So here the first graph, we're looking at the two functions being equal. So you're looking at where they intersect. And again, I'm going to show you how your calculator will find those points for you. You don't have to do any work. It's super great today, okay? You just have to know how to use your calculator. Now for this one, the solution, f of x is less than, so you're looking at where they meet, of course. And here they're showing you for a less than symbol, you're looking for, of course, where it's below those points. If it was greater than, above. And we'll see all of this on our graphs, so we won't really have to do a whole lot of work. So So here we go. Solve the given equation or inequality graphically. So a little note, I'm going to show you where this is because I don't think you've ever used it before in your life, okay? So intersect function. But first we have to get these typed in our calculator. So you're going to put the left side is y1 and the right side is your y2. Now if you remember, last chapter we set these equal to 0 minus, and we looked at where it hit the x-axis, where y is 0. It is the same thing. You'll get the same answers. It's just a different way to do it, just a different way I'm going to show you today. But you will get the same thing. Okay, so let's get these typed in, because we're going to clearly use them for all of them. So y1, I'm doing my 2x squared plus 3, hit enter, and then 5x plus 6. Honestly, I probably could solve that one quicker algebraically if we're going to get right down to it. Okay, I'm going to hit graph. And now notice too, your calculators, you got the different colors on the side. So the first one is blue, second is red. So I'm going to look when I hit graph where the blue and the red intersect, where they meet. There's the blue. Okay, now first let's talk about our window. I feel like there's 2 intersection points. Clearly there's this one here. I think there's one off the screen. I need to see the one off the screen. So now I need to change my window. You can try to zoom out. I find that kind of obnoxious sometimes because I feel like it zooms it out too much. I'm going to change the window. I need my y-axis to go up higher. So I'm going to hit window at the top. I'm going to go to y max because we're at 10. And it's a little bit of a guessing game. I think it's a little far off. I'm not going to get too crazy. I'm going to put 20. I'm going to switch it to 20. And I hit graph. I can almost see where it meets up there. It's right at the very top of the screen. So I'm going to hit window. I'm going to go to 30, just so I'm not right at the edge of my screen there. So now I'm going to change my y max on my window to 30. By this point, I feel like I could have just solved it algebraically quicker, but hey, here we go. Okay, so I need the 2 intersection points. Your calculator is going to do it for you. The big menu for today, for anything today, whether we're solving these, whether we're doing eventually max and min, it's all in the same menu. You have to hit second, and it says calc at the top there, above trace. We're getting into that calculate menu. There it is. And we're going to do number 5, intersect. I want the intersection point. So I'm just going to hit 5. Now you can see my little cursor. I'm just going to put him over there close to the point. You can see mine's in blue, so it's on the blue parabola. I'm going to hit enter. It will automatically jump it to the red for you. You don't have to left arrow, cursor, or anything. Just hit enter. Nobody wants to guess. That's stupid. And just hit enter until it gives you the answer. Okay, so we're after, of course, our intersection point there. We want the x. We're solving for x, negative 0.5. So that's one answer. Let me put the graph back up because we have to get the second answer. I need the right intersection point. So I got to go through the same thing. Second, trace, number 5 for intersect. I'm going to have to right arrow, though, and cursor him over there because he's still hanging out at the other point. Come on, little buddy. He doesn't have to be right on the point, just close to it. It will do it for you. Okay, I'm on the blue. I'm going to hit enter. He'll jump over to the red. Enter. Nobody wants to guess. It's stupid. And my x coordinate, we're solving for x that I'm after, is 3. Gracie, do you want a hard copy of the homework? It's on the table there. On the right there. Look for, you got it. So that's how you're solving them graphically. Now we're going to do the inequality part. Okay, so we're going to put it back up. So the technology, I'm going to steal this picture so I can draw on it. All right, so we've got our points here. I'm just going to write on this one. This was, of course, our negative 0.5 for x. That's what I'm after. And this, of course, we've got the 3. Because you're solving for x. I don't care about y at this point. We're solving for x. Okay, so now we're looking at this part, the inequality, because we're doing it all in the same picture. Clearly, we have the same expressions. 2x squared plus 3 less than or equal to 5x plus 6. Okay, so the parabola we want it to be less than or equal to the blue line. I'm assuming yours are blue and red too. So I want the parabola, the blue, less than or equal to the red. So you're looking at this portion is what I'm after. That's where my parabola, the squared, is less than or equal to the red. Now again, we're solving for x. I have this whole range of answers for x. Anything from negative 0.5 to 3 is below my red line. So that's going to be my answer. I'm just going to go interval notation, negative 0.5 to 3. Got it. I'm going to do C in the left. Because you can see and C, is there. Now we're switching to a greater than. So I want the parabola, the blue, to be above the red line. So greater than, I'm looking at these pieces. So those two black pieces, two separate black pieces, which means two separate intervals for me. So this left one, you're clear out at negative infinity because it's going to go off the graph, and it's going to stop right there at negative 0.5. And notice it just has the greater than symbol, not the equal to, so I'm going to be conscientious here. I'm going to use a parenthesis. 4. And then my black picks back up here at 3, and it goes all the way off to infinity. Same spiel, parenthesis, because you don't have the equal to. So you can solve all of this off the graph. Do I think it's any quicker than if I just did it algebraic, like if I factored it and did it? I don't know. But just another way you can do it. So just remember your intersect function, all of that is second trace. You got to get into that, number 5. So much calculator skills today. More calculator skills. Okay, so this, pretty easy. I like this, increasing, decreasing. We're actually going to see one that has what we call a constant piece in it. So when we talk increasing and decreasing, you're always going to analyze your graph left to right, of course, just like you do order of operations, just like you read left to right. And you can see in this very lovely picture here, as I follow my graph left to right, this piece, it's rising, it's increasing, then it switches, it's falling, decreasing, and now it switches again to increasing. So that's what we're going to be looking for, those different pieces where it's increasing, decreasing, etc. And notice, you are looking, we're using these random variables, we are looking at the x coordinates. So if this was like 1 and 4, I would say I'm increasing from 1 to 4. Let's say this is 5. I'm increasing 5 to 6. You're decreasing 4 to 5. Again, I just made up those random numbers at the bottom. We're going to take a look at some here, a little more specific. But that's what we're looking for. Now you'll see too, this book doesn't cover it a lot, but I kind of threw it in here on this just to show you, because why not? You can also have what we call a constant piece, this little guy, a flat line. It is the same straight across. That is what we call a constant piece. Do you have to answer that for me? No. They're just asking you for increasing and decreasing, but we should be able to recognize a constant piece if you ask me. All right, graph gives the weight of a person at age X. Determine the intervals on which the function W is increasing or decreasing. So I just kind of set it up, increasing, decreasing. And then I just follow my graph left to right, and I just label I and D, what's happening. So as I start left to right, rising, so that's increasing. I'm just going to do this piece in black because it flat lines. Now, you don't have to identify this for me, but I'm going to throw it on here for fun. That's where it's constant, we would call that. And now I see I'm back to, as I keep following left to right, rising, increasing. Then it switches as I keep moving left to right to a decrease. It's falling there. And now it flat lines again to constant. So we just have to get all the intervals going for these different numbers. And again, we're looking left to right horizontal x. You want the x coordinates. So increasing. We start at 0. And it stopped right here is where it switched. So I'm just going to straight down and figure out, and go straight down there, what my x coordinate of that is. I'm just estimating off the graph. It's right there at 25. Now, just because I can't help myself, the love of math, it doesn't ask for the constant interval, but I'm going to throw it on here. I'm going to throw it on here. So it's constant, that little black piece, between 25, if I can draw straight down. Man, that's pretty bad. I'm going to erase that and redraw that. That was pretty bad drawing. It's constant between 25 and 35. Not that I asked for this, but I can't help myself. And again, you're estimating with the graph. All right, I'm back to this next green piece, of course, which picks it up here at our 35 to 40, a little tiny one. I'm going to put another interval in here. And then we have our final decrease one, which of course 40 to 50 it looks like. Now, other thing to talk about too is these brackets versus parentheses. I am not going to be in a twist whether you use brackets on this like I have it right now or parentheses. There are some textbooks write them like that. And the reason they put them like this, just to explain to you if you ever see it, they talk about the open intervals for x, which is increasing and decreasing. Sometimes they'll use open intervals because this point right here is in like multiple intervals. Like that's where it's switching from to constant. So it's kind of a pivot point. So that's why some textbooks will ask for open intervals and use parentheses. And here, I don't really care if you do brackets or parentheses because the directions aren't that nitpicky. As long as you have the right intervals, I'm happy with you. All right, another picture here. Sketch the graph, which I gave you the graph just for the sake of time. Find the domain, range, intervals it's increasing and decreasing. Okay, man, we've got a lot to answer. Let's do domain first. We'll just go in order. So remember, domain, x. So when I ask you for domain, I'm asking you how far left, how far right does your graph cover? Remember, this keeps going on forever. So I'm looking at this. This is going to keep going on. This is going to keep going on. So I'm pretty confident. I'm thinking it's all real numbers. Now, just to relate it back to, of course, if I don't have the picture, just the equation. So I'm looking at this, these x's. I'm like, oh yeah, I can put anything I want in there. I can square anything. I can cube anything. I can raise it to the fourth. Negative, decimal, fraction, you name it, I can do it. Remember, it's radicals we get nervous about for domain, and it's when you have a fraction with an x in the bottom. I don't have any of that, I can use anything. So interval notation, we can use negative infinity to infinity. You want to use the symbol, of course, all real numbers. You want to write out all real numbers, whatever makes you happy. All right, range. Remember, range, we're looking for y. So it's going to go off the screen, so it keeps going all the way down, of course. So negative infinity, because we always want smallest to biggest, so it's going to keep going down here all the way off to negative infinity. Highest point, bam, right here. So clearly, I need the y coordinate of that point. Now, you're estimating it off the graph, of course. It looks like it's at 40 to me. Got it. All right, increasing, then decreasing. All right, we are just going to follow this thing from left to right, of course, and we're going to classify. So as I start out here at the left, rising, increasing. I'm going to switch to green. Now it's falling, 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 decreasing. Then it switches, of course, increasing, another I. So we're going to have two intervals for increase right now. And it looks like two intervals for decrease. So always follow it, of course, left to right, and we're just going to estimate off the graph here. Okay, so this first red one, increasing left to right, we're at negative infinity for the smallest. And again, it's hard when you're estimating sometimes off the graphs here. It switches right at this point. And I'm like, oh, tricky. Mean, that's kind of a mean graph. Notice they're scaling the x-axis by 0.5. So that's negative 0.5, negative 1. Just catch that. They're scaling that one kind of weird. All right, so decreasing, I left off at negative 1, so I know I can start there. right to here, of course, it's falling. So 0. That's a sloppy 0, but work with it. Left off at 0 for my next increase. So increasing again was this piece. I need that x coordinate. And again, scaling by 0.5. So 0.5, 1, 1.5, 2. Got it. And then my final decrease, we left off at 2, and it's going to keep going all the way out to positive infinity. To infinity and beyond. So again, I think it's kind of hard when you have the picture of the graph, they do this weird scaling on the axes. I'd rather do like the next problem, where I just generate the graph myself and put it on a graph grid and can get a little bit more accurate points, answers, etc. So we're going to sketch the graph of that, and you can use your calculator, of course. Let's clear this stuff out. And we're going to type it in. We're not going to get crazy, but we'll get a few points off the table, of course. So I'm just going to do x raised to the, and you can just type in 2 divided by 3. Hit graph. Now remember, I changed my viewing window because I couldn't see that one point on that previous graph. That's a hot mess. I'm going to hit zoom 6 quick to put it back on my 10 by 10, so it kind of matches my 10 by 10 grid over there. Now I'm not going to get crazy here and write like 50 points down, but I'm going to take a look at the table and try to get a few nice points off of it and try to sketch it quasi-accurate. Clearly you can see I'm going to use -1, 1, 0, 0. It had 1, 1 on it. What else do we have? 8, 4. I'm going to put that one on 1, 2, 3, 4. And I think if I probably scroll, probably has -8, 4. Oh, yep, sure does. Okay, let's do that one on too. And I'm just going to kind of sketch it here. Got it. Okay. I almost rather make my own graph than have some picture provided one. Now again, it's asking us domain, range, the same stuff, increase, decrease. So domain, range, increase, decrease. I should probably abbreviate decrease so it doesn't look like domain. Let's put DEC for that guy. Okay, so let's start with domain. So domain, horizontal. How far left, how far right does it go? Clearly it's going to go all the way to the left, all the way to the right. You can put anything you want in there for x, so all real numbers. I'm going to go interval style today. Feeling interval style. Okay, range. Y's, remember. So think your y-axis. So I need the smallest, the lowest, to the highest. Okay, all right. Well, here's the lowest point, which is at 0, then I'm above. So I'm going to say from 0 to infinity. Okay. Increasing. Well, let's follow our graph left to right and label. So if I follow it left to right, this piece is falling, decrease. And then if I keep following, it switches here and it's rising, increase. I'm going to do the decrease interval first. Way out there at -infinity, and it stops right there in the middle at 0. And again, I switched it up. I used open intervals this time. I don't care if you have the parentheses or the brackets, whatever. Increase 0 to infinity. I've seen both styles. I don't get in a twist over the brackets or parentheses. Any questions on that guy? I'll have drawn these graphs. Okay, we are on the home stretch. This is time consuming to type all this stuff in your calculator. This is super easy. The next thing, maximum and minimum. I'm just going to show you how to type it in your calculator. So graphs, of course, have what we call a local minimum, a local maximum. That is a whole lot of words over there for something that's super, super easy. Because remember, generally your graphs go on forever. They're either decreasing, they're going to -infinity, or up to positive infinity. Well, sometimes it's helpful for us to know what we call the local maximum, your highest points in the curves here, and then, of course, your local minimum, your low point in the curves. Courtney, there's like a hard copy of that. Because obviously this is going to go off forever to infinity. That would go to -infinity. So we're looking at our local max and mins through the curves, the highest points on the curves. Now, you could have max, you could have a min, you could have more than one, you could just have max, you could just have min. You don't have to have both. Just depends on the graph. and your calculator will find it for you, okay? So find the local max and min of the function rounded to 3 decimals. All right, let's get this guy typed in. So y equals, as always, I'm going to clear this out, x cubed minus 8x plus 1. I'm going to hit graph. The only thing, that looks pretty good. I was going to say I might have to change my window if I can't see it, but this looks pretty darn good. So, power the smartboard just so I can draw on it. So I'm looking for this high point here through the curve, so that's going to be my local max. And I'll show you, your calculator is going to get it for you. And then clearly here's your low point or our min. Your calculator will do them both. So here we go. So second trace, everything's in that calculate menu, remember. I'm going to do the red dot first, the maximum, then I'll do the min. Doesn't matter what you do first, I'm just doing the max first because I don't know, that's what I feel like doing. So I'm going to do number 4. Now, I got to move my cursor over a little closer to this point. So I'm going to left arrow, and I want to put it on the left side of the point. Come on, cursor. Okay, anywhere on the left side of the point that we're trying to find. Because remember, we always work left to right. So start on the left side of the point. I'm going to hit enter. I'm going to cursor through, I'm right arrowing, I'm cursoring through the point till he's on the right side of it. I'm going to hit enter. Nobody wants to guess, it's stupid. And there we have it. And I'm just going to write down this ordered pair, rounded to 3 decimal places. So I've got negative 1.633. I already forgot what it said what it was. And y is 9.709. And I'm just going to label that that was our max point. And I'm going to do the min. So really the same process, but you're going to obviously select minimum. So second trace. Everything is in that calculate menu. Know and love the calculate menu. Minimum. Now same spiel. I'm going to put the cursor so he's over here on the left side of the point because we work left to right. Here we go, little buddy. I'm afraid to move it too quickly, otherwise it gets crazy on me here. All right, good enough. Anywhere on the left side, you're going to hit enter. I'm going to cursor through the point till it's on the right side of it. Good enough. Enter. Nobody wants to guess. Stupid ones. Okay, and I'm going to round that to 3. So I got 2.121. And I forgot already what the y was. Negative 6.425. And I'm just going to label that was the min. So the pretty easy stuff here. Pretty easy stuff. I would say the only thing you might want to make yourself a note on. Do you have a different point?
Yeah.
Did I type mine in wrong? Let me check my y equals good. I don't never know here. 8x cubed minus 8x plus 1. Okay, all right. So 3. I wonder if I accidentally hit maximum and that's why it messed it up as I was talking and trying to type. Come on, cursor. Irritating. I hate typing on this thing. You should see how slow I text. Oh, there. I might have, I think, maybe hit maximum. That's why it threw it up. How about that? 1.633, negative 7.09. Is that a little bit better? I have a feeling I accidentally maybe hit max and it threw it off. Or 1.63. 1.632. And it was what? Negative 7 point something. 709. There we go. Got it. Okay. So the only thing, like, you might just want to make yourself a note on is you have to, of course, know where to find all of this stuff in your calculator. That's part of what we're testing or quizzing you on. So just remember to find those max and min. We did second, and we did the trace to get you into the calculate menu. That calculate menu will be your very, very best friend.